In this video, we're going to learn how to divide polynomials. First, we'll take a look at division by a monomial. So we're going to take some polynomial and divide that by a polynomial with one term. Our first example, 30x cubed minus 45x squared plus 5x. That trinomial will be divided by the monomial 15x squared. As you see in the general rule above, we want to separate this polynomial 30x cubed and the 40 minus 45x squared and the positive 5x. All of those will be separated and individually divided by 15x squared. At this point, we're going to divide each separate fraction. So first, 30 divided by 15 is 2. X cubed divided by x squared is x. The minus sign will stay the same. 45 divided by 15, 3. X squared divided by x squared, that simplifies to just 1. And therefore, negative 3 times 1 is still negative 3, so that'll stay unchanged. 5 divided by 15 is 1/3. And x divided by x squared will leave x in the denominator. So my final answer for this division is 2x minus 3 plus 1 over 3x. It might be a good idea to pause the video and try example 1b on your own, and when you're ready, push play to see if you got it right. 4x cubed y divided by 4xy plus 12x squared y squared divided by 4xy plus 4xy cubed divided by 4xy. 4 divided by 4 is 1. X cubed divided by x, x squared. Y divided by y is 1. 12 divided by 4, 3. X squared divided by x is an x. Y squared divided by y is y. 4 divided by 4, 1. X divided by x, 1. Y cubed divided by y, y squared. And you should have this as your answer if you tried this one on your own. Division by a binomial. Here, before we get into that, I want you to recall long division, which you probably have seen as early as 5th grade, maybe 4th grade. If you can think back to then, long division. 400 divided by 16. We look to see, does 16 divide into 4, taking only one digit? No, it does not. Does 16 go into 40? Yes. How many times? 2 times. So the 2 goes over the 0 at the end of 40, and we multiply then 2 times 16 to get 32. So we first divided, then we multiplied. So divide multiply. The next step is to subtract 32 from 40, which leaves 8. And the next step is to bring down the next digit. So the 0 will go here. And then we have 80 divided by 16, which is 5. 5 times 16 is 80. So we divide, we multiply, we now subtract. That is 0. We would bring down the next digit, but there isn't one. And we're done. So 25 has a remainder of 0 because there was nothing left to bring down, and the number that we were left with after subtraction was 0. So the final answer here would be 25. These steps, divide, multiply, subtract, bring down, and repeat, you will duplicate over and over and over again, whether dividing just numbers like this using long division or dividing polynomials, which is what we're going to be looking at today. Example 2. X squared plus 7x plus 6 divided by x minus 1. Here this looks very complicated because we've got polynomials both as the divisor and the dividend. But we're going to break it down and use the same exact steps as before. First, divide x squared by x. And I like to write that division on the side. That answer is x. And so we're going to go where we would have put the answers in our last example, right above this division symbol. And we're going to put this in the x to the first column. All of the x to the first terms will be lined up in the middle, x squared terms on the left, and constants on the right, and they'll line up straight up and down. So after we divide, we multiply. This time we multiply by the -1 and the x, where before we just divided x squared by the x and we ignored the -1. Now it's time to pay attention to that again. So x times x is x squared. X times -1 is -x. We have done divide, multiply. Now we subtract. When you subtract, we're going to distribute a -1 to the x squared and the x term, so that will become positive. Basically, every time we subtract, the signs are going to change because we're distributing a -1. Now, x squared minus x squared is 0x squared. Perfect. We want that to go away. 7x plus x is 8x. So we divide, multiply, have now subtracted. It's time to bring down the next term, as opposed to the next digit in our last example. And now we repeat. Divide. 8x divided by x is 8. So that will go in the constant column in our answer section. And we have done the division again, so we multiply. X times 8 is 8x, and 8 times -1, -8, multiplying this term from our answer by both x and -1. After divide and multiply is subtract, so again the signs change. 8x's cancel away, and 6 plus 8 is 14. We repeat, we bring down. There's no term to bring down, so we're finished. But unlike the last example, we have something left here. It's not 0, but rather 14. So x plus 8, remainder 14. How we're going to write that is this: x plus 8 plus the remainder of 14 divided by x minus 1. This is the portion of the original polynomial that I was not able to divide yet, since I had 14 left over. And so we write it as a fraction still to be divided. So this would be your final answer: x plus 8, remainder 14. Something important to pay attention to is that whatever the degree of the polynomial is, you must start obviously there and then work in descending order: 3, 2, 1, 0 on the exponents on the variables. In addition to that, we need to make sure that every single exponent is presented, or represented. So 3, then we jump to a 1 and a 0. We were missing a 2, x squared. So we need a placeholder. In this case, the x squared is the one that will be holding a place. So we add 0x squared. It does not change the value of this original polynomial, but it allows us to have a cubed column, a squared column, which wouldn't have existed otherwise, and you'll see why that's important in a moment, an x to the first column, and a constant column. So all of our work will remain in those columns. And we follow the same process as before. Divide. 2x cubed divided by x equals x squared. If we did not have the placeholder of 0x squared, there would have been no place for us to put x squared as our answer. Now, after we divide, we multiply x squared by x and by 1, which gives us x cubed plus x squared. And after we divide, multiply, we subtract. So all of the signs change. This now becomes a minus. And 2x cubed minus x cubed is not 0. Uh-oh. This tells us we've made a mistake. When subtracting, this first term should cancel completely if our division was correct. So let's go back and take a look at the division. 2x cubed divided by x equals 2x squared. Originally, we kind of ignored the 2 and just dealt with the x term, or the x factors, not the constant there, or the coefficient of 2. So we can't forget that. And now 2x squared times x is 2x cubed, and 2x squared times 1 is 2x. Let's erase in there a little bit. And do this a little clearer for you. Alright, and that was positive, but now when we subtract it is negative. Now 2x cubed minus 2x cubed cancels. This was done correctly. Good thing we have that check available to us so that we're able to catch mistakes prior to getting all the way to the end of a problem. So we divide, multiply, we've just subtracted, we bring down negative 6x, which was our next term, and we repeat. So negative 2x squared divided by x equals, let's not forget the coefficient this time, negative 2 divided by x is still negative 2. The x squared divided by x is now just x. to the first. So we have negative 2x as the next part of our answer, which goes in the x to the first, or the linear column. We're going to multiply that negative 2x by x and by 1, and we get negative 2x squared minus 2x. That was divide. Multiply, we subtract. So in doing so, the signs change on the second binomial here. Negative 2x squared plus 2x squared cancels, so our division was correct. Negative 6x plus 2x is negative 4x. We bring down the next term, negative 7, and repeat. Negative 4x divided by x equals negative 4. That goes in the constant column. And negative 4 times x and times 1, negative 4x minus 4. We subtract, our signs will change. Negative 4x plus 4x cancels, so our division was good. Negative 7 plus 4, negative 3. There's nothing left to bring down, so we are finished and have a remainder 3. Again, we'll write that answer. 2x squared minus 2x minus 4 plus 3 divided by x plus 1. This is, or can be, quite confusing because of all of the little details and steps that you're going through. It's helpful to maybe write those steps down on the side, divide, multiply, subtract, bring down, repeat, and kind of check them off as you go through to keep track of the process. The math involved here is not necessarily very difficult. It's kind of a review of the properties of exponents and basic simplification that we've looked at in the earlier videos of Math 022 here. But without paying attention to the detail and following those steps in order, students can get very confused here very quickly, and one tiny error could be major problematic for an answer. The next question: x cubed, x squared, x to the first, x to the 0. We have all of the exponents already written in descending order, and once we started with the degree 3, we went 3, 2, 1, 0. Everything was present, and so we do not need a placeholder. And we can set our problem up. X cubed minus x squared plus 5x minus 7 divided by x plus 4. Again, we're going to keep our columns cubed, squared, first power, and constants in order. We start following the same steps, which were to divide. So x cubed divided by x is x squared, which will go in the x squared column. After divide is multiply. X squared times x cubed, x squared times 4, plus 4x squared. After we multiply, we subtract, which changes the signs. So x cubed minus x cubed cancels, which we want. Negative x squared minus 4x squared is negative 5x squared. We have divided, we have multiplied, we have subtracted. Now it's time to bring down the next term and repeat. So divide. Negative 5x squared divided by x equals negative 25x, which will go in the linear column. After divide is multiply. Negative 5x times x is negative 5x squared. Negative 5x times 4 is negative 20x. We subtract, so the signs change. This cancels, and this is 25x. Bring down, negative 7. And we repeat, 25x divided by x equals 25, which will go in the constant column. And we multiply 25 times x and 25 times 4. We subtract, so the signs change. 25x cancels, and a negative 107 is our remainder. So our final answer here, x squared minus 5x plus 25 minus 107 all over x plus 4. You could also write this as x squared minus 5x plus 25 plus negative 107 over x plus 4. Really, it kind of comes down to preference. If you always add the remainder, then the sign, if it's not positive, so it would be a negative sign, that would be attached in the numerator. Or you could just subtract the remainder since the remainder was negative. That comes down to personal preference. Example 4. This is one that you might choose to pause, try on your own, and then push play to see if you got it correct. And you might not be comfortable to do that yet and want to see one more before you try it on your own. Either way, that's okay. X squared and then x to the 0 power. So we're missing an x to the first. We'll need to make sure to have that as our placeholder. X squared plus 0x minus 25 is divided by x plus 5. X squared divided by x is x, which will go in the linear column, x to the first power. Then we multiply x squared plus 5x. We subtract, the signs change. First term cancels, so our division was correct. Negative 5x the answer. We bring down the negative 25 and repeat. Negative 5x divided by x equals negative 5, which goes in the constant column, and we multiply. Negative 5x minus 25. We subtract, so the signs change as we distribute that negative 1. And this first term cancels, but also the second term this time cancels, and so we have a remainder of 0. What does that mean about our answer? X minus 5. It means that x minus 5 and x plus 5 are both factors of x squared minus 25. That term factor is something that, particularly with these polynomials, is going to come back in later videos, in later courses, and in later chapters. But x plus 5 times x minus 5 will equal the polynomial x squared minus 25 when you do that multiplication. The reason we can say the answer is a factor again is because the remainder was 0. Example 5. This is one for sure that I'd like you to try on your own prior to watching me go through this problem. So again, this would be a good time to pause, try the problem, and then push play to check to see if you got it correct. X cubed plus 0x squared minus 2x plus 4. Again, we needed the 0x squared to be a placeholder so that I have my x squared column to be putting answers. That is divided by x minus 2. We divide x cubed by x and get x squared. We multiply x cubed minus 2x squared. We subtract. And 2x squared is the answer there. So we bring down the negative 2x and repeat. 2x squared divided by x is 2x, which will go in our linear column. And we multiply 2x squared minus 4x. We subtract. The signs will change. 2x. We bring down the next term and we repeat. 2x divided by x equals 2, which goes in the constant column. We multiply. 2x minus 4. We subtract. The signs change. And we have a remainder of 8. So our final answer, x squared plus 2x plus 2 plus 8 over x minus 2. In this video, we have only looked at a few examples of polynomial long division, but I hope that working through this process, divide, multiply, subtract, bring down, repeat, and kind of talking through that over these last examples, that process is something that was starting to be drilled into your brain that you will remember and recall. It kind of breaks down this division problem into much more manageable steps.